All right, can everybody see that presentation?
Yes.
Oh, yeah.
Awesome.
Yes.
Kayla, take it away and tell me when to click, please.
All right. Yeah, I mean, you can, well, I'm Kayla. I think you guys know who Jessica is, but we're going to talk to you guys a little bit about civil engineering. We're both civil engineers at Galloway with kind of varying levels of experience. So we'll be able to share a little bit about that. I am coming up on 4 years out of college that I've been doing this job, and Jess is a few years ahead of me. So we can kind of talk through some of this stuff, and especially what will relate to some of the elements of your guys' project. So we can go to the next slide. So kind of before, and this touches on probably some of the stuff that was in the videos for those of you who did get a chance to check those out already, but both what Jessica and I do is kind of one subcategory of a very broad industry that we call civil engineering. With a degree in civil engineering, you can go through all different types of career paths. Some of the kind of big ticket ones are listed in this little bubble chart here, but you can take it a whole bunch of different directions. So I guess that's just something more to kind of keep in mind for you guys, since ACE is all about exploring all different industries and just getting exposed to that. So there's a whole ton of different things. A couple of them that are on here, like structural engineering, you can probably kind of think about what that is. So it's designing buildings and other structures like that. Geotechnical has more to do with soil sciences, which is super complicated, way more than you would ever think of. Water resources, I think one of you had brought up that was something that was kind of interesting from the water quality and water resources side of it in that video. So within civil engineering, there's just a ton of variety of what you can do, whether you work in the private sector, public sector, there's infinite options really. So with that being said, kind of the stuff that Jess and I are going to talk about today is really related to kind of a couple of these, but we call it land development is really the branch that we put ourselves under, which you can kind of think of as like a jack of all trades. We deal a little bit with a lot of these topics that are listed and just kind of overall comprehensive design for construction sites like the project you guys are working on. So we'll deal a little bit with water quality, obviously planning and site layout stuff, utility designs, which we'll touch a little bit about here in a second, all the way through seeing it through construction. We're working with geotechnical engineers and structural engineers. So we kind of get to interact with a lot of these different components. Next slide, please. So I guess to start you guys off, we're going to start thinking about something that we briefly touched on last week when we were looking at site analysis, which is just utility services that you're going to need for any building that you're going to kind of consider to be, not a camping experience, we'll say. Obviously, you can go outside of that or you can do without these things. But if you're looking at something that's more of a modernized and developed site, whether it's a tiny house like you guys are designing, or a grocery store, or really anything, you're going to have to think about how you're going to get all of these different utilities to your building so that it's operating and has the kind of necessary comforts. So the listed items here include water, storm sewer, sanitary sewer, electric and gas, and then phone, cable, and internet. And this little infographic is just kind of to think about different places in your home where each of those are really going to play a key factor in, that the use of that space for you. So obviously without water, things like your sink and your shower and your dishwasher and washing machines wouldn't be working super well. Obviously electricity, we want to have lights, gas to heat the building, and things like internet. I think we all are especially aware of how important that is. So those are kind of the major categories. We'll go to the next one. So with all of these different utilities that are being run throughout the cities and into all of our buildings, there's certain things that we can kind of identify just from visual inspection when we're looking at a site. I think at least for those of you who are in our Zoom group, we did do kind of a Google Earth walk around the site and kind of pulled up some of these things, but there's a couple different just examples that I pulled up on the screen of items that you can kind of get a sense for what utilities are around and in that area and kind of supporting the development. So kind of going around, I guess, do any of you guys recognize any of these pictures, any of the students? Do you know what any of these could be or what they would be for or the utility they're related to? Any thought? I won't make it too interactive, but. No.
One of them has a date written on it.
I feel like some are pretty easy. You're not gonna convince me.
The gas pipe thing.
Yeah, very good. Yeah, so that who is that talking? Sorry, I can't see you.
Sander.
Sander, thank you. Yes, so Sander, that's a very good observation and good reading. So this this little post right here on the top right is a picture of kind of an identifier that they'll use specifically if you have a high pressure gas line running through an area. So you definitely don't want someone to accidentally hit that, or it could be a pretty big deal. Some of the other stuff we've got going on here, some identifiers about where the sewer could be, a storm sewer inlet. We've got a transformer, fire hydrants, and some overhead electric lines. And a couple of these I know we've already identified on our site, which is pretty cool. So if we go to the next slide, these things are kind of the surface level items, but really what's going on underground is a lot more interesting and complex. All of these utilities are more or less routed through the city, primarily with the use of roadways as a major corridor to kind of get them to any of the end users. And from there, they can branch off to service any individual building. But you can kind of see all of these colored lines that are being shown are really supposed to be the different utilities that are going on underground. So that green pipe is the storm sewer. You've got a bunch of red lines that are probably some kind of a dry utility, probably electric, since they are also kind of near a bunch of those street lights and light poles. You've got the blue, which is the water, and those are also colors that you'll see probably pretty frequently that are kind of an industry standard to identify different utilities. But when you're designing utilities, at least from a civil engineering perspective, we have to consider different individual design constraints for each of these based on how they're delivered to the end users and what the purpose is. But then we also have to consider just how this whole underground matrix works and make sure that nothing's running through each other, that they're all kind of staying in their own lane. So kind of an interesting thing to think about next time you're driving around the roads, just all this fun stuff going on below the ground that you have no idea. So we can go to the next slide. So Jessica went through our site with kind of a similar eye and basically highlighted all the utility information that we have given to us from our site plan as part of our RFP. So you can see based on these different colored lines, you know, the surrounding utilities, and as we kind of expect, and like we were looking at in that previous diagram, a lot of them are existing through those major streets. And then you can see those little branches that go off into different sides, which are kind of where all of those existing surrounding buildings and things are already in place. So we can kind of take a good educated guess and understand what's going on between all of those things. This is kind of a refresh from last week, but do you guys remember any of the things that we pointed out on our own site or kind of on the use of this on the use of this diagram here. Like, do you see any important utility features, maybe some of those above ground that we had noticed here? A little zoomed out too. What about Gabriel? Do you remember any of the things we talked about?
I remember seeing all this before. The only thing.
What if we think about one specific utility? Let's take water as an example. Gabriel, are you talking? I think sorry, I couldn't hear you. Zoom things, of course.
I know, I was trying to.
There we go.
To remember.
So did you guys talk at all in your breakout groups? I think we might have been in the same one together about, like, did we notice any of the like fire hydrants or maybe some of the street lights and those overhead lines that we were looking at for electric?
Oh yeah, the fire hydrants, the light poles.
Mm-hmm.
That's what they're called.
Yep, exactly. So we can kind of connect the dots there. Yeah.
Mm-hmm.
Yep. So now we'll just kind of be thinking about those a little bit more and kind of where that's all coming from. But awesome. Thank you.
You're welcome.
Oh, so I think let's delve in. I'm going to talk a little bit about water and sanitary stuff, and then I think Jess is going to talk about some storm sewer design as well. So a couple different aspects on the surface of what we design. So like that lead in, the water design for our sites is composed of a couple different things, but these are just a couple examples of really what the water services are important for our sites. Obviously, we kind of touched on this before with, you know, our faucets, showers, everything that has water in our buildings. So if we're thinking tiny homes, I don't know if they would have their own washing machine or dishwasher, but they'll definitely probably want a shower. They'll probably still want a place to wash their hands. Those are all going to be important. This picture of the open fire hydrant is a way that we actually can test for pressures within the underground system by opening that thing up, and it shoots a ton of water, which is really cool to see. And then the bottom right picture is a fire sprinkler that you might see. Well, I don't know if you guys have really been in school, but next time you go back to the building, they probably have these running along the ceilings in there. Apartments, bigger commercial buildings, things like that. So we all know why water is an important service to have in our buildings. So if we go to the next slide, this is just an example of how we as civil engineers would basically design and detail out what the water utilities and main lines for a site would look like. So this is a plan and profile view of a water main running through a street, which is ultimately being put in for a grocery store. You can see from this, I wish we'll probably post this after, I would imagine, so you guys can zoom in a little bit more, but the top line, that's kind of a darker line along the profile view, is representative of the ground, and then everything are different pipes that exist, both our water that we're designing and showing here, as well as other utilities that we have to look out for. So you can see it, for the most part, follows the a certain depth below our surface ground. But there's a couple places where it has to be a little different just to accommodate for everything else that's going on. So some of the design considerations that we normally take into account, I kind of listed out on the next slide. So one of the big things for water mains and water services that's unique for this utility is the fact that it's a pressurized system. So rather than, there's kind of, miles and miles of pipes that are actually getting the water from its source, which is some kind of a big storage tank in your city, all the way home to your tiny home, to your own house, to your grocery store. And how it gets there can be a couple different methods, but for the water services, it's a pressure system that drives that. So it can go up and down and kind of follow the contours of the earth, but along the way, we also have to take into consideration that every time you bend or you go through a pipe size change where you get from a bigger pipe to a smaller pipe, the energy within the system, you lose a little bit of energy every time you go through one of those. So we call those system losses, and we have to account for those and make sure that when we get to the end user, they are still able to get water with good pressure. I don't know if you guys have ever been in somewhere where the water pressure was a little too low and you turn the sink all the way on and maybe the flow of water isn't as much as you want it to be, or I always notice it in the shower if I have a really hard time rinsing out my shampoo or something. But it's super important to make sure that that water pressure stays within a certain range so that it can be kind of for the end user's benefit. So the other things to consider, obviously, how people pay for the water that they're using. So we have to design systems to keep track of that for whoever is servicing it. Fire protection is a big one for water. So hydrants and where those are placed to make sure that if there is a fire, someone can reach each building. So we'll want to definitely take that into account. So if something does, obviously in a bad situation, if someone's house catches on fire, they need to make sure that there's a hydrant close by so they can put it out. Irrigation is also a big one. I wanted to mention reclaimed water since it's super interesting and kind of a newer deal, but that's a really creative way to be a little bit more resourceful. So next we'll talk about sanitary, which is kind of the flip side of the same coin. So for everything that we bring water in, there's also going to have to be a drain that kind of takes the wastewater and nasty stuff out of our house. So that's where sanitary sewer kind of plays a role. I don't think it's too crazy to think about why we need sanitary. Obviously, a big benefit to being in a developed part of the world where we have flushing toilets and showers and things like that. So let's go to the next slide here. And this is, again, just kind of a similar layout of something that a civil engineer would put together as part of a construction plan set to get a sanitary sewer actually built in real life. So lots of important information there. And it does look a little bit similar to the last one, but there are some key differences that we can kind of talk about in the next slide. So the big thing with sanitary sewer is this is a gravity draining system. So whereas with water, you have pressure that can kind of push the water from point A to point B, with the sanitary sewer, you have to make sure that wherever you're starting is kind of the highest point, and water tends, for now, water tends to follow the rules of gravity and flow downhill. So we have to make sure that we have enough fall across our system to actually get all of the sewage and waste and nastiness out of wherever it's coming from. The location of these is obviously super important, and we want to make sure to avoid any kind of conflicts that could be issues. Tree roots can cause major issues for people's sanitary services, especially for older parts of the city. And we just want to make sure that everything can obviously, if you're trying to flow something downhill and there's something in the way, that doesn't really work. So location, vertically and horizontally, is super important with all of these systems. And this little schematic just kind of shows some of the other things that can go wrong that we try to avoid when we're designing our systems. So I think that might be my last one, but let me just, yeah. So then I'll hand it over to Jess to talk stormwater.
Awesome. Thank you, Kayla. All right, so now we'll dive into the third major of what we call wet utilities after water and sanitary sewer, which is stormwater. And we get to deal with stormwater because no matter where you're at, it's going to rain at some point, and it's going to be problematic for us if we don't attempt to take care of it. So basically, kind of going back in time when we had, very spread out development, more rural communities and a lot of open ground. We had a lot of fields, we had a lot of native forest, and basically what would happen when it rained is the water would kind of stay on the surface, some of it would, and run off and maybe pond there for a little while, but we had just plant material over a native soil type material, and there's usually what we call void spaces in soil. So most of that rainwater could kind of land on the ground and then percolate down through the soil void spaces, and then just kind of re-follow the water cycle, re-enter as groundwater, and then go back up as rain down, and just follow that standard water cycle. So what happens when we as civil engineers, structural engineers, architects, etc., start building buildings and roads and all of these other things that really improve our quality of life, we start adding what we call an impervious surface, because if your roof or your highway lets water percolate in, you did something pretty wrong as an engineer. We don't want that to happen. We want those to repel water and be impermeable to water, so that we're not getting rain in our house, we're not getting, water and then ice within our highways and our bridges and things like that. So we're creating this sealed surface over the ground now in a lot of areas and a lot of square footage of it. And so what happens is, as it starts to rain more, we're generating a lot more runoff, a lot more surface water right after a rainstorm than what used to be there. So now we have to find a way to accommodate that water. Otherwise you get, and I think I have some pictures of this as an example a little later, but basically parking lot flooding, roadway flooding, it looks like your street is a river, and really these flooding issues if you're not taking care of that storm water. So what we do is we create a series of storm infrastructure to kind of handle, divert, and direct that water away from where people are, away from where houses and vehicles and things like that are, and back to somewhere that water likes to be, like a natural creek or river or lake. So we do that by installing a series of underground pipes, storm inlets. You might see different types of storm inlets as you kind of walk around or drive around. You might also see manhole lids, and you may have seen a detention or a water quality pond and an above ground pond. So this is kind of what can happen when we're not managing our stormwater, which is why we take this into account. So, one thing we run into with storm is that existing city systems, so those existing pipes that have been in the ground for 10, 20, 30 years, the existing inlets, they were designed for a smaller development, for a 20 years ago, 30 years ago population of people and development. And so now we're starting to get close to the capacity of those systems and overwhelm them. So basically, anytime we do a new site, a new development anymore, we have to detain that stormwater and then basically control the rate of release of that stormwater so that it matches the historic runoff from when that site didn't have pavement on it, when it was just a grass field, just to prevent system overload and not flood anybody out downstream of us. So you may have seen some detention ponds. They basically look like big grass-lined basins in the ground, kind of inverse hills. They might have rock or riprap in them. But it's basically just a place where we can temporarily store stormwater so that we can slowly release it back into the system without impacting downstream. So that's kind of thing one of stormwater would be rate control, just so we don't flood anybody out. And so there's the above ground ponds, and we also have a bunch of different underground systems that have been developed over the last couple of decades. So they've got these kind of like inverse half moon underground plastic chambers that can go underground. We've also got more of these box structure type, still kind of a stackable Lego-like system. They make a concrete version of that as well. And here's some different manufacturers, and we'll post this presentation so you can take a look at this if you wanted to dive in on the civil side a little bit with this project. But we can basically provide stormwater detention and rate control either above ground or underground. Underground is great when we don't have a lot of surface area. Above ground is great when we have extra land. And so the other factor with stormwater that we really want to consider is the quality of that water. So when we're in a developed area, an urban area, you know, there's all kinds of stuff that can get into that water, and it doesn't matter where you are. Water is eventually going to be flowing to a river, a lake, the ocean, somewhere like that. And we want that water to be clean and safe, because we drink that water, animals drink that water. We like tubing and fishing and doing recreation activities in that water. And we don't want to be in there if there's oil slicks in it or old couches or other weird things that you sometimes find in some of our water around here. So there's a lot of different things that can affect the water quality. You know, the big one is trash. You guys have probably all heard about, you know, the trash piles that are kind of forming in the ocean. And that's all coming ultimately from our developed areas, from people littering and things like that, and it ultimately washes into the ocean. But we also have a lot of other things that can really affect and damage our water. So one is chemicals, and that can be anything from you spilled oil in your driveway when you were working on your car, to the fertilizers that we're using on our grass, to pesticides, to industrial pollution, kind of anything in that realm. And then we also have sediment that can be very harmful, which is just very, very small, like minuscule suspended particles of dirt, basically. And then micronutrients are a big deal too. So that's probably the biggest one for ecosystem standpoint. When you have a lot of micronutrients, so like a nitrogen, a phosphorus, a potassium, a magnesium, things like that, a lot of those come from fertilizers or additives in fertilizers or are used in industrial processes. But those micronutrients, you can't see them. You can only tell they're there if you test for them. But if those go into an ecological system, it can cause algae growth. And then the algae will start eating so much of the oxygen in the system that it turns it into an anaerobic environment, and it can start killing off your insects, your fish, and that can in turn affect larger species like birds and other species that are eating those fish and insects. So it can really wreak havoc on an entire environmental system if we're not taking care of the water. So there's a few things, and I know you guys watched that video on water quality, but we'll just breeze through a few ways that we can kind of improve water quality locally on our site, rather than trying to deal with it, let somebody downstream deal with it. We want to try to improve the water on our site and make sure it's clean when it leaves, because if everybody does that, we'll have clean water everywhere, which hopefully that doesn't take another century to get to. Hopefully it's faster than that. But we can basically take water and run it through like a biological type system. So a grass swale or a grass buffer, because that'll filter out a lot of the larger stuff like sediment and trash. And grass will also start to eat some of those micronutrients like phosphorus, like nitrogen, and pull that out before it gets to a waterway. We could also do something a little bit more dressed up than a grass swale, like a rain garden, where we're actually adding more plantings to that and letting the water stay there for a little longer. Kind of same idea, just pulling out all of these harmful things from the water. And most of the mentors today have chosen rain gardens for their background for water quality. You may have also seen or heard about permeable pavement. So rather than using an asphalt or a concrete that has this sealant on the top where water can't penetrate, this type of pavement actually lets water infiltrate straight back into the ground. and it has a granular material underneath of it that'll start to filter off and peel out some of those harmful things in the water. You know, another thing that City of Denver just implemented recently that we're starting to see around here is green roofs, and that takes care of water that's falling on our rooftops rather than that's just collecting any trash or debris or dust that's up there and flowing down into a storm system. Now it's actually utilizing that water to kind of be in a symbiotic relationship with the plantings up there, and the plants are cleaning that water out for us. And then you also have some proprietary devices, some underground systems. So if you can't do any of these surface type features, you can still route your water through an underground system to get that improved quality. And so we've got like vortex separators, basically these hydrodynamic systems that just spin really fast, and it kind of lets all the sediment settle to the bottom and all the trash and oil float to the top and cleans the water that way. There's systems with chemical filters on them that pulls all the micronutrients out and sediment sinks to the bottom. So lots of different options for improving the quality of water on your site. And then another thing that's becoming a lot bigger, it's becoming a lot more popular, and it's a really good thing to do for civil engineers, is called LID, low impact design. And if you're interested in any aspect of civil, I would recommend looking into this a little bit more, because it really is a cool approach that we're starting to take as civil engineers. So really what we try to do is we try to look at the site as a whole, the engineering design as a whole, and create a system, create landscaping, create a site layout, create detention, water quality, all of these pieces that will cause the stormwater runoff to mimic as closely as possible an undeveloped site. That way we're having basically zero effect on anybody downstream of us, which is really cool. So part of what that entails is taking, you know, this is kind of the traditional way of designing a site where you just have a bunch of pavement and roof area. When you're doing something more of low impact design, you're taking that pavement area and you're decreasing the volume of it. You're trying to get water to flow in. You're using permeable pavements. You're taking runoff from your parking lot and routing it into a landscaped area instead of just capturing it and piping it off site. Definitely a good little example graphic there. And then this one's kind of a little harder to read, but basically you've got your runoff from your streets and you're trying to route it to these landscaped islands on either side so that water can soak into the ground, just like it did if it was undeveloped. It can kind of spread out and not all be concentrated in one location. And it can kind of sit there for a little while and even evaporate back up into the atmosphere versus just sheet flowing off on the pavement of a site. So this is kind of the basic formula that we use to calculate runoff for an area. It's your total runoff in cubic feet per second of stormwater, of rainwater that you're generating on a site is basically a function of how much rain is falling, how impervious is your site, so how much landscape area do you have versus asphalt versus gravel versus, you know, other materials like that, and then how much area do you have. And then, you know, really it's also, with all this being said, it's really, really important as civil engineers to work with the natural landscape and not try to fight nature. If you've got a site that's really steep and you try to put your building on the downhill side, you're probably going to have stormwater issues because water's all flowing towards your building. So definitely good to analyze your site up front and make sure that everything's getting laid out in a way that makes sense so that you're not fighting against nature, you're kind of working with nature. And then real quickly, here's some pictures of stormwater that has failed, because this is what happens when civil engineering goes wrong or we get a very, very large storm. These were from the 2013 storm that was just crazy big in Colorado. And that's Chesterfield, Missouri, which basically the river sits about 30 feet higher than this entire town. So the entire town floods every time the river overtops, which is how you work against your landscape if you're a civil engineer. So that's it for me.
I'd love to hear Jess and Kayla. Can y'all speak, unless you had more in your presentation, Kayla, can y'all talk for just a second about like what excited you and what made you want to be a civil engineer?
Do you want me to go first, Jess? Okay. So I decided, I actually went to school initially and I thought I was going to be a doctor. So kind of had a different path in mind. And as soon as I got to school, I really liked science and math. I had always liked those topics in college, or in high school, but I wasn't really vibing with the whole medical track, which was the only thing I knew about for like smart mathy people. So when I started learning about engineering, there's, all different types. And the thing that I was drawn to the most about civil engineering was mostly to do with the fact that you're more working in, the real world and dealing with people and looking at sites that are outside. And it's just a lot more interactive with your environment and with the people who are utilizing your design elements, which was really appealing to me. I didn't want to be hunkered into my office all day just crunching numbers. So I thought it sounded like a more social engineering. And I think it's really cool that we can impact and shape the way that our communities turn out to be, so your legacy lives on far beyond your own career, which I think is awesome.
Yeah, and I was always that kid. I always liked math and science, and I really liked Legos when I was a kid. So it was kind of going in this direction of an engineering architecture type direction. But what I really like about civil engineering is, one, water. I'm very passionate about water and water quality and making sure that our environment is clean, and what we're doing to develop is not harming our planet, on the other side of it. I want really good, high quality life for people, first class developments, great water, electricity, all of these like first world amenities that we're so used to without negatively impacting our environment. So that was a big passion point for me. And I went land development because it, like Kayla said at the start, it's a jack of all trades type profession. So I'm working on utility design one day, and then I'm grading a site and working on the slopes, and then I'm out on a construction site looking at an issue, and then I'm writing a report. And it's so jack of all trades that you never get bored with land development in particular. You're doing 50 things one time each instead of doing one thing 50 times.
Do you guys have any other questions about the presentation or anything we talked about, or just civil engineering in general? And I'll jump in at once. We explained it all. Well, thanks for listening, guys.
Actually, I would just add one comment. As a landscape architect, we're fairly generalized. It's not just planting. That's actually a pretty small part of what I do. So we do sort of encroach on some of the civil engineering. An ideal world, I'm working with the civil engineer and we're developing some of those low impact development strategies. So, while they might be looking more so at some of those quantities of stormwater, I might be working with them then to figure out what materials are going to be best for that, some of the plantings, but certainly stormwater and stormwater quality is a really important part of landscape architecture as well.
Oh. We're gonna, Jess, do we have an activity? working on that?
I think the activity was gonna be, so we kind of randomly assigned you guys to teams, into groups to kind of work on the project moving forward. And I think the activity was gonna be to pull up the base map and just kind of start to talk about, you know, what do the grades look like on one side versus the other? Water flows downhill, right? So if there's one corner of the site that all the water wants to flow to, what should we put there? Should that be our water quality feature, our detention feature, or should that be a tiny home or the community building? And then just start using that to help inform how we're going to be laying out our site. You know, where's the water line? If all of the water lines are on the south side of the property, we probably want to try to keep our buildings towards those so that we don't have to go all the way across everything else. So just trying to think, just observing, you know, what we have to work with out there and starting to use that to inform our site layout.
Awesome. So did any, I think we asked this already, but if any of you students particularly want to be on each other's team, we'll probably be in 2, maybe 3 teams going forward for the final presentations, depending on how many other people kind of find their way in the next couple weeks. So if anybody wants to be on a team with someone else, y'all can send Jess and I a direct message so we can make sure we put you together. If not, it will be all random, and may the odds be ever in your favor.
Thank you guys for being patient with us because